Hello. All right. Let's oh yeah. I forgot to publish. So the animation we did this morning came out pretty good. I forgot to post that on Twitter. Let's do that now. And I'll show it on stream. Came out pretty nice, I think. Don't really see much noise. It's pretty smooth, all things considered. I think most of the stuff here is just like compression artifacts. So yeah. I might actually wait till after stream to post that on Twitter. I just want to get straight to working on this blog. So this background, I don't like this. I opened this up here. I was looking at doing some image editing on it. I don't think it's going to do. So what I'm going to do is I'm going to generate a new background. I actually figured out what I want. I want like almost galaxies or space. And I'm pretty sure CC0 astronomy images. Like, I swear to God, there's so much CC0 astronomy, so okay, here we go. So Wikimedia has this stuff. So there's lots of good things as a basis. Oh my God, there's actually so many good things here that could be used for patterns. Here we go. This is something I'm looking for. Must give credit. No. Okay. See, this is the thing. I'm not giving credit for this because it's gonna be just in the background of my website. Ooh, public domain. Let's just check the source just to be sure. Fairly certain this is in their public domain gallery, so but awesome. Okay, let's use this as a base. Wow. Alright, gonna try to generate a background using this. Shouldn't actually be too bad. There might actually be too much noise from quantization here, but man, I think this should generate a very nice background because it has so much data to work with. I could actually code while I wait for this. I'm not gonna let it run for the full 12 minutes. I just did that just so it'll just keep running. Interesting, I can actually already see it's repeated the same pattern. Patches there, yeah, so the quantization is not good. Let's try no quantization. no pattern size. This should give very interesting effect. Alright, I'll put this in another tab. And what I just want to do to begin is I want to start writing this minimal autoencoder, and I'm going to write it in a JS fiddle so anyone can go and edit the code easily. I'm going to base this off of the little autoencoder we wrote yesterday. Also, I really hate browser editors, so we're probably going to actually do the editing in gedit. So we can just actually put the same HTML right here. And I love JS Fiddle. JS Fiddle is so nice for just sharing. Also the C and C++ equivalent of Godbolt. Oh my god, it's awesome. Alright, there we go. That looks good. This is generating streaks because of the low pattern size. It's actually not too bad, but we'll increase it a little bit to make it better. So yeah, I'm gonna rewrite this without all the matrix stuff, but a lot of the image loading and this will be the same, so I'm still gonna need these functions and like the entry point and all that. So this is the JavaScript that I'm gonna be putting in the JS Fiddle. I'm just writing it right here because these sometimes bug out, I find. Ooh, this is generating streaks as well. It's gonna clear up when it does the next pass, but it's really interesting how this actually works. All these different streaks are the different patterns that could fit in there, and when it goes over again, it's going to fight between them. Yeah, you can see some of them show up more than others. It combines ones that are similar. It should resolve itself after like 10 or so passes, but another easy way is just making a large pattern size so it copies the image nearly exactly. I actually think there was some compression in that image here, and I should actually have reduced it in size. Yeah, there's definitely a good amount of noise or compression here. I'm thinking a lot can be gained by reducing. Yeah, that's way smoother. Okay, I'm probably going to process it on that instead. The noise really messes with the generation. Also, making it smaller just makes it way easier. Ooh, I wonder if it's going to learn to fit together these. Oh yeah, it's doing a decent job. It's gonna hopefully stitch these up. Oh, it did that one kind of nicely. Still working on these. Or that is actually the same thing as that because it tiles around. I think it's just going to end up erasing this because it's not going to fit in here. Oh my god, this is already 130 lines. Okay, so I need to reduce this. I need to make this way simpler. Way simpler. How can I minify this? It still ended up with some chunks there. Let's try again. As we begin coding. Alright, settings, or actually let's do our settings up here. Chunk size of pixels input to encoder, input size times 3, red, green, blue, just to be completely clear, like how much data it's using. So this way I don't need to load any of the settings or anything here. Training samples. Train coder, or wait, no. Okay, let's, I'm gonna I'm rethinking how I'm gonna do this. I'm gonna design this minimally. I'm gonna completely change how this works. This actually isn't gonna do the same thing of just encoding a single image. It's gonna progressively do the same image over and over again in random chunks. So when the image is loaded here, it's actually gonna start a sequence or process, like a repeating loop. So it's actually gonna, I'm actually going to need to initialize a canvas and all that. Initialize them here. Rendering our image. I also need pixel data. canvas for drawing image. And we'll just set it exactly to the image size. Load image pixel data from canvas. I gotta keep pressing save. It's just such an automatic habit now. Okay, this isn't gonna work without quantization. Letting it mix together a few pixels that aren't equal. There we go. Now hopefully we can get one that gives us a mix of the starry background and some nebulas and things. That's pretty nice actually for a background. This might work. Except right now, tiling, it looks like just a line going straight down. Straight up or down. Yeah, there we go. We either need to cut it off or form some like horizontal details. Just try a bigger pattern size. That's pretty good, as long as it fixes up these seams. Alright, now that we've loaded the image data, we can just begin. We actually need to initialize our encoder. Encoder. Artificial neural network, single matrix of weights, no biases and no activation functions. So neural net, array of weights. Initialize weights. Must be scaled so inputs of all one proportionally. Alright, never mind. We'll just do I think it's 1 divided by input output size. Actually, I'm going to need this total input in another place as well, so let's put this up here. encoder number of pixel values in chunk, input chunk. I'm not deleting this old code yet, just in case I need it for something. But I'm going to start the main loop now. I'm thinking I don't need these functions anymore. I can put all of this in the loop. And I'm looking, this actually should be just around 100 lines, which would be really nice. I also just realized I didn't start up Discord when I got on my computer this morning, which is... I normally do that. Alright. So yeah, I think I'm just gonna progressively load in random chunks. Alright, this generates a random X and Y that's within the image. We subtract the input size so that it doesn't generate a chunk that's like offset the corner of the image. It needs to stay like within the image bounds. So this, I actually just realized, will break if the image width and height is smaller than input size. I'll put that somewhere. Alright, I gotta forget doing optimization. I'm so used to optimizing things. In this, I just need to write just like super simple code that's not optimized. Oh my god, it's actually easier to do the optimized way. Alright, so normally I would have wrote these things in variables before, but I'm just trying to do this as simple as possible. Like I would have buffered this in a variable, but simplicity, no optimization. I think it is more minimal though for me to write. Hold on, I'll write the neural network code, and then I'm pretty sure it's actually going to be better for me to put it into functions. I just realized I'm probably gonna need some other image data. No, actually, never mind. I can just grab image data from the canvas to do this. I was gonna say, I can't just like write out the image data here, because this is our source data, so I need another buffer to do the writing out. Alright, now we decode, and then I'm going to need to have this running forward code again. And then we're going to need to do... I'll try putting it in a function and then, or after I write it twice. Run output, run encoding backwards through neural network weights, transpose matrix. And yeah, this code is actually basically the same, so I'm just going to take it from here. Because the transposed is actually a bit tricky. You have to increment the weights differently. Alright, so then that actually gives us our decoding, where now we're going to display this. And this is actually just going to be also a good testing point of whether or not this works or not. So I'm going to try and get that set up and then test that. I also just realized I need to add this canvas, or oh yeah, I forgot I left that running. I'll just overwrite all of this. Drawing image body.innerHTML. Just erase everything and just add the canvas. Alright, and now right here we need to output random chunk, decoded chunk, and draw output chunk on canvas to visualize encoding. Show how well encoder is doing. That's going to be very similar to this, but we're going to need to get out data. We need to get a chunk from the canvas. Now this is going to be the opposite, I think. So I actually need to put this not an input, but in decode. Decode by running encode by running input through neural network. I'm thinking if I need to do math max, I think just floor. Actually, I might not even need to do anything, just multiply by 255. Let's just try that. Okay. Hopefully this will do it. Oh, this is pretty good. And it just erased all the parts I thought were good. Well, shit. Okay, let's try this. Oh, I actually think I want to do this because I use JS Fiddle so much. Hold on, let me see what that is. What is this survey? Oh my god, it took me away from my fiddle. Holy shit, that's so badly designed. Oh my god. I assumed the devs were smart enough to open up the fiddle. Oh my god, to open up the survey in another tab, it just replaces the tab that you have open. So it just erased my unsaved JS Fiddle. Ah, god damn it. I was just talking with my mic off. Shit. Alright, so output doesn't exist. It's actually encode. I'm not doing anything with this, so I actually need to draw this to the canvas. So we put the image data back at offset X and offset Y. C is not defined. C. Oh. It's supposed to be O. I'm just checking if there's anything else I'm missing. I think it's good. Get image data is not a function. That's supposed to be C2D. There we go. All right. It's actually supposed to be dark like that. Because that's what happens when it starts. If I set the output size to 1 and the input size to 1, it should actually be good. Or better. It's random, so. Anyways, that's good though. It shows the basics are functioning. And I think I might need to make it faster than request animation frame. Like I think I'll just do set timeout because it's gonna have to do a lot of samples. So, all right, let's train the network now. Calculate error derivatives. Something like this might even just work. I think I'm just going to focus on this background for a minute or so and just try and get this looking decent. Because it really bugs me that I don't like my own background on my blog. Okay, that's 100% repetitive. How does this look in the middle of processing? That's actually decent right here, but it clips off right there. right there. It looks like it's gonna clear it up right now, though. Super curious if I can fix it like this. This might even be a decent background as well. Even with these lines going down. No, it doesn't tile. It's actually interesting. This pattern right here loops around to right here and then doesn't match up with itself. Like when it goes down for a second loop. So this actually, this galaxy or astronomy photo actually isn't great to use to try and generate a tiling pattern. Since there's so much noise. My issue is when you do get a tiling background, it ends up just being these stars back here. I want some of the galaxies, stuff like that. I'm just gonna keep incrementing these until I start getting somewhat nice features. This actually isn't bad, as long as it keeps these in. It is breaking the tiling though. There we go. Nope, that's noisy. Yeah, so they lose the details after they iterate too many times, or it favors the repeating patterns way too much. This one might actually be good. That one's not bad, or it's better. It starts to tile. I actually thought this was going to be able to find some tiling patterns much better in here, but I guess not. I guess it does make sense though with how much like contrast there is with these parts. Actually, you know what? Hold on. Let's try increasing the quantization and pattern size massively. I believe if I increase the pattern size enough, it should kind of offset the quantization by detecting, yeah, these large patterns of galaxies. Okay, this might work. This might work now. Hopefully it doesn't just erase all this with that background. No, it's keeping it. Very nice. Does seem like it's working. Not sure how well it's tiling though. Let's try and take this here. How does that look? Should be repeating. Yeah, okay, that's a lot better. Nice, that does look like stars. You can see the repeating pattern in it, which is fine. But what we're trying to get is just find decent quality settings so that now we can ramp it up to like a 300 by 300. So then it's way harder to detect the repeating pattern in it. And honestly, I'm thinking I might just go back to some kind of this old pattern I had here. This was started as vines, but I didn't really like the vines. I might try and find some other plant or something like vines. I just said the same thing. Ivy is what I meant, which is also vines, but something with leaves instead of just vines. Alright. While this is loading, let's go back to writing the autoencoder here. So now we need to do the actual training. Network. So for this, we just need to loop through the input, calculating the derivatives between the decoded and the input. Error derivatives of decoded versus input for training neural network. So there we go. That gives us basically the direction the pixel values output by the neural network need to go to be more correct. Derivatives forwards through network to create decoding error derivatives through network to create encoding derivatives. So we have to run the network forward again. train neural network. And then repeat. Oh yeah, and then training is actually just like the encoding. We run forwards through the, wait. Never mind. I gotta normalize input. And then, yeah, then we can do everything just like normal. Train neural network. So we need to the normal of the input. I actually wonder if I can do this without normalizing. Normalizing makes it way faster. Calculate sum of input for normalized input. Train neural network using encoding errors and input. Or based on encoding errors. And then it just becomes basically the same, right? Yeah. Encoding errors stored. Encode. Decode. And then this needs to be scaled by our input sum. And then we train the neural network using this. So neural net weight index plus equals dv times input. Oh, interesting. This is kind of working. Wait, reassignment of encode. Where else is it assigned? I think the JS Fiddle debugger has no idea what it's doing. Reassignment of encode. Oh. No, it knows what it's doing. I'm an idiot. I named this function the same thing. I'll just call this run neural net. There we go. Can I use the console here? Oh, nice. It's all not a number. Okay, everything's working incorrectly. Well, that sucks. That sucks. Well. What could it be? I'll just try disabling the training to begin. How did I initialize this before? 1 divided by input size, yep. I wonder, am I like not scaling? Maybe my input is not a number. No, my input is good. But encode and decode is not a number. Okay. Nice. That's actually good. And this is actually tiling decently now. Hold on. See how this works. Okay, that's better. That is an interesting pattern to it. I think I'm gonna do this off stream, because like that's using a lot of my GPU power. That's a lot better though. I definitely like that a lot more. The darker background. I want to get something that tiles better, but it's definitely the idea of what I'm looking for. Alright, let's get this basic encoder working. I'm super happy with how this is laid out so far. It's basically in 125 lines, which I think is very reasonable. And I got in all of the information that I wanted to. So now I just need to figure out why this is throwing not a number. good old debugging. Maybe my neural network's not the right size. That could actually be it. 768. 8 times 8 times 3 times 4 output. 768. No, it appears good. Let's do console.log weight index. No, yeah, everything is good there. So for some reason, encode doesn't get set, or these end up being not a number for encode. Alright, none of the input has not a number. Oh my god, a whole chunk of the neural net isn't set. Oh my god, I'm an idiot here. I did total input instead of neural net.length. Such a simple mistake. Alright, this should actually fix it. Yep. Alright. It's not completely fixed yet though. We gotta make sure it trains properly. Oh, awesome. There it goes. So I think I should actually start it with a black image because it's actually hard to see. It's hard to see where it's filling in. But yeah, wow. There we go. It's too bad you can't, is there a way to zoom in on JS Fiddle? So we take our auto-encoded image and we look at it, actually especially now if we compare it to this source input, you can see 100% how the auto-encoded has lost definition. But it is compressing 8 times 8 times 3. It's compressing 192 values into 4. So you can see actually if we do an output size of 1, it'll do it even worse. Things will actually be completely blocky and they'll only have 2 colors. I see it's chose basically pink and black. But this is what the autoencoder does, is you tell it to take an input chunk of pixels and turn that into a much smaller dimension encoding. And so what that ends up doing is either encoding it in grayscale or in these sort of detailed chunks. And you can see some of the chunks actually kind of do match up with the stars. But as you increase your output, even just for example to 64, which is a third of the actual data in the input, I'm also thinking, so anyways, just to show the point, this is like, look at how much better an encoding this is. So this is obviously still lossy. You can see the little blur it applies, but it encodes it way better. Thanks Windows Antivirus. I really care what you have to say. But as you let it run here in the JS Fiddle, it'll actually get higher and higher quality as it learns to encode those details better. Anyways, what I was thinking is right now it's doing random samples, which takes a really long time to fill in sometimes. Because it sometimes, like, yeah, basically goes all over the place and fills in the same values multiple times. I'm thinking I could do... Okay, I can't remember. Hold on. I think I have this in my bookmarks. No, maybe not. It's unreasonable effectiveness of quasi-random sequences. Yeah, by Martin Roberts. Yeah, Martin Roberts. Okay. Here we go. So this will give a way better sampling distribution. It's just a few more lines of code. How many lines of code are we at? 125. I'm very satisfied with that. it's still minimal in my books. So we would implement that right here. Replace our offset X and offset Y with this. Now I don't know if I want to do this because this is kind of advanced for the tutorial, but it does give a really nice result. Step. Oh wait, no, iteration. X equals 0.5. This iteration times 1 divided by G. I'm just going to compute these values in the console right here, so I can just do multipliers. So this is going to be more code, but it should give such a nicer result. Because it should now not sample the same points nearly as much. And we're going to increment iteration on this last one. And this is supposed to be 1 divided by this times this. And if I do end up using this, I'm going to like add a reference in the code here to the article on that. Because then people have a source for the actual information that I'm, or the, I don't know, sources for sources. Oh yeah, look at that distribution. It's beautiful. It fills it in so much quicker. Oh, that is a beautiful use of the golden noise. Okay. So now if we do 64, should encode it pretty nice, pretty quickly. Alright, just give it a minute or so. I think I should also do a little measurement of how much loss there is. But I think visually it's pretty easy to tell. I'm really happy with this. It's blurry, but I believe if I leave it, it should get pretty good. Let's actually see how much it's improved. Just while I talked about that, it improved. So yeah, you can definitely see it doesn't get the same features as Sharp. But wow, I think it does a really good job for I just realized it never fills in this corner right here. This one line. I actually wonder if that's a bug. Like if I need to add -1 or something somewhere. Oh yeah, look at that. Now it's nearly perfect. Beautiful. You can barely tell the difference now. Alright, I'm super happy with this. I'm going to save this code actually. think I am. So I'm going to use this. So I'm going to put a source to this up here. Select quasi-random chunk from image. Discrepancy. Sampling. How do what's the best way to reference this? I don't want to write too much about it. Low discrepancy sampling. I think that's decent. Did I spell discrepancy right? Yes, I did. Okay. Nice. Alright. That's beautiful. It doesn't make the code any longer, but it just makes it function way better. Amazing. Okay. That's going to be it for me for now. I'm going to be back in like an hour or two, and then we're going to write the actual blog post on that. That was like the base code that I'm going to share as like an example for people to easily learn in like 100 lines or so. But then the blog post is actually going to go into detail about how the chunks are being encoded, what each neuron in the neural network weights is actually doing. The more interesting stuff, I think. Alright, I'll see everyone around. Thank you for watching. If you have any questions, I'm on Discord or Twitter. Bye-bye. Hope you have a good day or good evening wherever you are.